Hey guys, welcome back. This is another example of an inclined plane problem, and we're also going to throw in some friction with this. So that should make it a little bit easier for you to keep practicing these problems if you see another example. So the first one we're going to do is number 108 on page 138, and the problem is, in loading a fish delivery truck, a person pushes a block of ice up a 20-degree incline at constant speed. So we have 20 degrees and we have constant speed. The push the push is 150 newtons in magnitude and parallel to the incline. So here's the block of ice, and here's the push of 150 newtons. The block has a mass of 35.0 kilograms. So the question is the incline frictionless? So, is there zero coefficient of friction? And so we want to identify forces, and in this case we've got a couple different forces. We already have the push, which is kind of labeled as 150 newtons. We have the force of gravity straight down, and we also have the normal force. Now, we're not going to put in friction right now because we want to see whether or not there's friction. And so this becomes a Newton's second law problem, and the tricky thing about this is to realize that if there's a constant velocity, what does that make the acceleration? Well, it's going to be zero, right? If the velocity is not changing, a is zero. So that means that the net force parallel to the incline will be equal to zero, and the net force perpendicular to the incline will also be equal to zero. Okay, so now let's zoom in a little bit and draw these forces a little bit more clearly. Once again, the force of gravity splits up into two forces. Force of gravity perpendicular and the force of gravity parallel. And this right here is 20 degrees. So this is going to be Fg cosine of 20, and this is going to be Fg sine of 20. Or in other words, that's going to be mg cosine 20 degrees and mg sine 20 degrees. So now we take these and we plug them into our normal equations. And I think I'm going to zoom out, and that's a little bit small, so let's just do it like this. Fg perpendicular is Fg cosine, which is mg cosine, and Fg parallel is going to be Fg sine, which is mg sine 20 degrees. Now we have to plug that into our Newton's second law. So what are our parallel forces? Well, let's set up our axis. So up the incline and perpendicular to it is positive. So we have 150 minus Fg parallel is equal to 0. Now we don't know if it is, we want to check. So we have 150 minus mg sine of 20. So we get 150 minus 35 kilograms. Oh, and this is newtons, by the way. And then 9.8. And then sine of 20. We want to know if that's equal to 0. And it turns out that 35 times 9.8 times the sine of 20 is only 117 newtons. So 150 newtons minus 117 is not equal to 0. So to answer the question, is this ramp frictionless? We have to say no, because we're moving with a constant speed, but gravity alone is not enough. So gravity alone only gives 117 newtons, and that's not enough to balance the 150. So we know that there's got to be some kinetic friction going down the incline. And that actually changes our equation. It's still going with a constant speed, so F net is 0. Now we have 150 newtons minus 117 newtons minus F kinetic, and that's still equal to 0. And this tells us that the kinetic force of friction for part B is about 33 newtons. Okay, now we could take this one step further. This isn't in the question, but if we wanted to find the coefficient, we know that the coefficient comes from muffin. The force of friction is mu times the normal force. So mu is kinetic friction divided by the normal force. Well, in this case, how do we find the normal force? We have to go back to the perpendicular forces, and we've done this before. F normal minus Fg perpendicular is equal to 0, or F normal is equal to mg cosine 20 degrees. Bring that down to here. So we have 33 over, and then we have 35, 9.8, and then the cosine of 20. So this gives us a coefficient of about 0.102. Okay, so there you have it. There's another example of how to deal with friction type problems. Now, let's do one more example on the same video, just because you're already here. Let's do number 99 on page 137. And for this one it says, a packing crate is placed on a 20-degree incline. Let's draw that. So this is number 99 on page 137. So here's our incline. Packing crate, 20-degree incline. If the coefficient of static friction is 0.65, will the crate slide down if it's released from rest? Okay, now in this case, we already know what the forces are. Okay, just give us some room here. We have the force of gravity, which has a perpendicular parallel component, and we also have the force of friction. So we have normal force, we have force of gravity, and if it was going to slide down the incline, the force of friction would go up the incline. So this is going to be a static force of friction. It's going to be Fg parallel is right here, and Fg perpendicular will be right there, and we have the same angle. Okay, so this is the same setup, just more practice, and now we want to know, will the crate slide down? Now if the crate slides down, then Fg parallel will be greater than friction. That's what we want to figure out. Now we don't know the mass of this crate, so we could be in trouble. Well, let's think about this. The force of gravity parallel is mg sine of 20 degrees. The force of friction is going to be mu times the normal force, mu static. And we know from doing this before that the normal force is equal to Fg perpendicular, or mg cosine of 20 degrees. So we have a pretty interesting expression. We want to know whether mg sine of 20 degrees is greater than mu times mg cosine of 20 degrees. So check this out. mg cancels on each side, and bring the 20 to the other side, divide by cosine of 20. And when you do sine over cosine, that's the tangent. Do we want to know, is the tangent of 20 greater than or equal to 0.65? And so we plop it into a calculator, and the tangent of 20 degrees is 0.364. So it is not greater than 0.65. So no, it will not slide down. Now a follow-up question would be, what angle does it have to be at in order to just start sliding down? So in that case, we have the exact same setup, and we would have the force of friction equal to the force of gravity down the incline. We would have mg sine theta equal to mu mg cosine theta. And doing the same thing as before, we get the tangent of the angle is equal to mu static. And in order to find the angle, we have to take the inverse tangent of each side. So the angle is equal to the inverse tangent of mu, which is 0.65, and We take that. It turns out to be 33 degrees. So not until we get an angle of 33 degrees will it start to slide. And you can actually try this with your desks. The desks in the classroom don't necessarily have a coefficient of 0.65, but oftentimes you can put a book on it, you can put pencils on it, you can put all sorts of things on your desk, and they won't slide because the angle isn't large enough.